Python has many types of built-in data structures: lists, tuples, dictionaries, sets, and more. Scheme has lists, and lists in Scheme are like the linked list class that we created in Python. Every Scheme list is a linked list. Lisp was created in the late 1950s, and back then it seems computer scientists really liked confusing names and acronyms. So they invented a procedure called cons, which is a two-argument procedure that creates a linked list. Creating a linked list is only useful if you can access the first element and the rest of the list. And there are procedures for that as well. Char is the procedure that returns the first element of a list in Scheme, and cdr is the procedure that returns the rest of the list. There's also a built-in symbol nil, which evaluates to the empty list. So, to create a linked list of length 1 containing the value 2, you would write cons2nil, which would build a cons with 2 and the rest of it being nil. Oftentimes that's drawn in this way, where the slash just means that the rest of this list is empty. Now, Scheme lists are displayed as parentheses with elements separated by spaces. There is this underlying linked list structure, but the standard way of displaying a linked list doesn't show that structure. Instead, it just shows the elements. So if I cons2 a nil, I build this cons, and if I cons1 and cons2 nil, then I build this cons, where the rest of the list is a list containing 2. But evaluating this expression in Scheme doesn't show me this structure, instead it just shows a list containing 1 and 2. If I define x to be a list containing 1 and 2, I can look at x and see the whole list. The char of x is the number 1, and the cdr of x is the list containing 2. If I cons1, cons2, cons3, cons4 nil, I'm building a structure that looks like this. But displaying it in Scheme looks like a list containing 1, 2, 3, and 4. So all Scheme lists have a linked list structure. You access their elements using char and cdr, but you display them as a list of elements. Let's take a look at some more demos. Here I'm going to load a web-based interpreter that we use for the course, because it will draw the linked list structure of any list that I create. So if I define S as cons1, cons2 nil, S is a list that's displayed like this. But if I draw it, I'll see the linked list structure. And draw is not built into every version of Scheme, but it is built into this one so that we can see what's going on. What happens if I cons3 onto S? I'm allowed to do this. When I call cons, the first argument can be anything. The second argument either needs to be another cons or nil. Cons3s gives me a list 3, 1, 2. And cons4 onto cons3 onto S gives me the list 4, 3, 1, 2, which, if I draw it, shows me that it has a linked list structure. So what if instead I cons4 cons3 nil onto S? Think about what this is going to display. I suggest you pause for a moment until you have some idea of the answer. I'm going to show you the answer in 3, 2, 1. Cons creates a list where this is the first element and this is the rest of the list. Since S has length 2, this cons has length 3, and the 3 elements are a list containing 4, 3, and then the number 1, and then the number 2. If I draw that structure, it will show me that it is a 1, 2, 3 element list with a list as its first element, and then a number as its second, and a number as its third. If I build this structure and I look for its car, I will get the list for 3. And it has a car, the number 4. Hopefully you're getting the hang of it. Let's try an even trickier one. Remember that S is a list 1, 2. What happens if I cons S, nil? Think about it for a second, maybe pause the video, and I'll show you in 3, 2, 1. It's a list containing the list 1, 2 and the list 1, 2 as elements. Drawing this one shows that they're in fact the same element twice. A list containing the list 1, 2 and the list 1, 2. Let's look at a few built-in functions related to lists. So if S is 1, 2, I can see whether that's a list or not. It is. And remember that sharp T is Scheme's way of saying true. Is 3 a list? No. Is the car of S a list? No, because the car of S is the number 1. Is nil a list? Yes, it's the empty list. How can I tell the difference between the empty list and a non-empty list? I could use the null ? predicate. And I can also build lists with the list procedure. List 1, 2, 3, 4 builds a list with contents 1, 2, 3, 4. Now it's still a linked list structure underneath. I can, for example, get the cdr of the list 1, 2, 3, 4, and that will show me the list 2, 3, 4. If I had this cdr and I const 0 onto the front, then I'd have 0, 2, 3, 4.